Yeah. So you gonna make one?
Good morning, everyone. Let's wait for 1 minute. Students are still joining. Just one more minute and then we can start. Anyone has any questions? Mm, 19. So just one more minute. In the meantime, let me just review what we did in the previous two classes. And I uploaded this document on Canvas also under chapter 4, so you can check that. This document is on chapter 4 module, and it's just basically what we have done so far. Talk about the definition of the probability, what is random experiment, and when we talk about random experiment, we are talking about predictable outcomes, but we don't know which way they will come. And this is the review of some set theory that we learned. And let me make it empty set, null set. And this is called your subset, union, intersection, complement. We talked about all this in the class, previous two classes. So just want to go over this. What is a Venn diagram? Yes, question? So the definition of Venn diagram, probability model, what does it consist of? It consists of one is your sample space, one is your event. And if you already started working on your homework assignment, there are questions where it's asking you if it's a right probability model or not. If it's a right probability model, again, you need to look for the sample space and events. And then also you need to satisfy two probability rules. And we talk about these rules in the earlier class, where you are looking for the probability of an event is between two numbers. And if it's those one of those two numbers, you know that either that event is not happening or that is the only event happening. Other than that, the probabilities are either in fractions or decimals. So you look for the set of total outcomes and then divide how many times the event is occurring with the total. And then probability of the sum of the sample space is 1. So when you add all the probabilities, it should add to 1, less than or more than 1. It's not a right probability model. We talk about general addition rule. So the addition rule of two events. And then we will see what kind of events we are working with. So this rule keep on changing, or you can say this part keep on changing depending upon what kind of events we are working with. So general addition rule says A or B is the probability of their individual minus the extra part or the intersection that you have between those two events. And this intersection is 0 if you work with disjoint event because there is no intersection. And when there is no intersection, this part turns out to be 0 and you will just get the sum of two events. And this is the fourth rule we talk about, that P does not happen is 1 minus P happen, A happen. So if we are talking about this, and this is my sample space, that's my probability of A. And if I'm saying the probability of A happens, so I'm talking about this whole part. And anything outside this is not A, other than A. So we call it as A complement. So whatever outside A in the sample space is complement of A. So A and A complement, when you add these two, it gives us the sample space. So sample space is the sum of A and A complement. So if I know one thing, if I know A, I can find the probability of A complement, because I know that the probability of the sample space is 1 using the second law or second rule for the probability. So probability of A plus its complement gives me the probability of the sample space. And probability of the sample space, we know that it is 1. And then if I need to find this, I'll move this here, which is this part. If you want to find this, then you move this, which is your this part. And when you add everything, you get. So we have done this part, and last time we also talked about independent even. So let me write that part also here. So general addition rule for independent events. And we did an example of independent events using the discrete probability distribution, where we were tossing 3 coins, and then X was my number of heads. So let's do the same example, and you have a very similar question in your homework assignment where it's asking the probability of either 3 boys or probability of 1 boy, at least 1 boy in the 3 trials, or 1 girl. So you have very, very similar question in your homework assignment. So here I'm talking about the coin, but when you read the question, you can make sense out of it, or you can just compare that question with this example. So here we are tossing a coin 3 times, and then we are looking at the number of heads we obtain. So X is my number of heads. So when we are tossing a coin 3 times, first of all, we know that tossing a coin is an independent trial. So when we are saying they are independent, so that means knowing the chance of one is not going to affect the chance of other. So if I'm talking about first trial or first toss, I get a head or a tail. Head and tail, I don't know which one will I get. But if I know my first trial is head and I toss a coin again, head or tail. So knowing the probability or chance of this head in the first trial is not going to affect the chance of my second trial. And we call them independent events. So those 2 events are called independent if knowing the probability of one or the chance of one is not going to affect the chance of second one. And when we say these are independent events, then their intersection is the product of those 2 events. And when the intersection is product of those 2 events, the general addition rule that we were using it before. So let me erase this first. So the addition rule that we were working is A union B is their individual probabilities minus their intersection, and their intersection is the product. So it will be and if you know the probability of A and B, then you can definitely find this. In the homework assignment, there are questions where it's saying there are 2 independent events and probability of A is this, probability of B is this. If the question is asking what is the probability of A or B, you can use this. But if the question is asking what is the probability of A not happening or B not happening, so A or B is this, right? When we are saying A not happening or B not happening, we can do the same thing. A not happening means the complement of A. And some places you see this or this. So complement of A complement of B. So we are still using the same formula. If we are talking about independent events or disjoint events, since I'm using C here, if I know the probability of A is 0.4, can I find the probability of A complement? Can I? Or can you find the probability of A complement? We just use this rule, right? So if you are looking for the probability of A complement, is 1 minus probability of A. And you have the probability of A. So probability of A complement is 1 minus probability of A, which is 1 minus 0.4, 0.6. Similarly, if you know probability of B, you can find the probability of B complement and plug these values. If you already started working on your homework assignment, you see there are questions where it's not asking you probability of A union B straightforward. Instead of that, it gives you the probability of A and probability of B. So it's asking you probability of A not happening or B, or probability of A not happening, union B, or A union B complement. So it is asking you all these questions. So once you know the probability of A or B, A, probability of A, probability of B, you can find its complement and then see what question is asking, this part, or this part. And then you can do that. So let me come to your slides. And then let's quickly go over this example because you have very similar questions in your homework assignment as well. So same thing, you are tossing a coin 3 times and X is your number of heads you obtain. So when you toss a coin 1 time, you get a head and a tail, either a head or tail. Same thing, you toss it again, head and tail again, and then toss it 1 more time, head, tail. And same thing, if you have tail in the first trial, you get head and tail. And if you have head in the second trial. So first of all, how many possible outcomes are here? When you toss a coin 1 time, your sample space is either a head or a tail, right? When you toss a coin 2 times, that means I'm talking up till here. When you toss a coin 2 times, your outcomes are 2 heads or a head or a tail. And similarly, when you toss it 3 times, your outcomes are not 4 anymore. Now, 2, 4, 6, 8, depending upon how many trials you're doing. With 1, you get 2 more outcomes, and then with these 2, you get 4 more outcomes, so you have 8 outcomes. So first 2, and then 2 to the power 2, 2 to the power 3, and you keep on doing, and you get that many outcomes. So first you get 2 outcomes, and then 4, and here you will get 8 outcomes. And we can see what are those 8 outcomes. The first outcome is this, head, head, head. And the second outcome is this, head, head, tail. And similarly, you can find your all 8 outcomes. And this picture or the pictorial representation is called tree diagram. Tree diagram is very useful to see the visual picture of your outcomes, what you are getting, instead of just looking at those outcomes or memorizing. And for each event, you cannot memorize. So tree diagram gives us what information we have, and then you can make a tree diagram, and then you can look at their individual probability. And this tree diagram is very helpful when we'll talk about conditional distribution and when we apply Bayes rule. And these are the 2 last topics or 2 topics that we will cover towards the end of this chapter. So again, tree diagram is a pictorial way of representing, and you don't have to make a tree diagram. You can make a table also, and if that table helps, you can use that table as well. So once you have this outcome or these 8 outcomes, and let's quickly write what are these. So head, 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 tail, and the next one is head, tail, head, head, tail, tail, and so now it's tail, tail, head, head, tail, head, tail, 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 head, tail, tail, tail. So these are my 8 outcomes that I get. So this is the use of tree diagram. With the tree diagram, I can see how many outcomes are there and I can write each outcome clearly. So this is my sample space and I have 8 outcomes. And each outcome has a chance of getting 1 out of 8 in the sample. And each outcome is independent of other one. Now, the question in the beginning says that X is my number of heads. And when I'm saying number of heads, so number of heads I will obtain here is max 3. I can obtain at the max 3 head. I obtain 2 head also. 2, 1, 2, 1, 1, and 0. So the number of heads X will have is either no head, 1 head, 2 head, 3 head. And again, we are talking about the set of outcomes that we can count. So we are talking about discrete probability model. And then we have these 3 possible outcomes we have. So now just looking at that, can I say the probability of getting no head is 1/8, 1 head is also 1/8, 2 head is also 1/8, and 3 head is also 1/8? Can I say that? Can we say that? Do you think it's a right probability model?
No.
No. And again, why not? Because each outcome has 1 out of 8 chance. But I cannot just say that 0 is 1/8, so 1 is also 1/8. I need to see how many times or this outcome is appearing or how many possible outcomes in my sample space that has only 1 head. So if I'm looking at 0 head, oh no. Okay. There was an update and I was like, I don't want that software update in the middle of the session. So here, when we look at this, first of all, we know that there are 8 outcomes and each outcome has a chance of 1 out of 8. But when we are changing the equation or changing the question is asking me, what is the probability of X when X is the number of heads you obtain? The number of heads you obtain is not 8. The max number of heads we obtain is 3. So either no head, 1 head, 2 head, 3 head. And this example is very similar as the one we did with the dice. When you roll 2 dice with one color red and green, you have 36 outcome and each outcome has the probability of 1 out of 36. And when we look at the sum of those two, the probabilities changes because the outcome will be from 2 to 12. And this is exactly the same. So we are talking about this. This is my sample space. Now I'm looking for the probability of 0 head. So in which condition I'll get 0 head or no head when I get all tails? And that is only 1 out of 8. So this probability is correct. 1 head. So how many times I'm getting 1 head in my sample space in no particular order? I get 1 head here.
3.
3 and 1 head here and here. So this 1/8 is not correct. This should be 3/8. What about 2? How many times we are getting 2 heads? Here, here, and here. So this is again 3/8. And how many times we get 3 heads? This is the only option. So 1/8. And when you look at this probability model, you can see the first rule satisfied. And first rule was satisfying before also. All of these are between 0 and 1. But the second rule was not satisfied earlier because when we had 1/8, 1/8, 1/8, 1/8, when you add everything, it was 4/8 or 1/2. And our second rule says that probability of the sample space should be 1. And when you add all these, this will give you 1. So your second rule also satisfies. So once you know how to find the probability of each outcome from the sample space, you make a table and assign individual probabilities. So we call them as xi's, and this is pi's. So this one, let's say, is x1, x2, x3, and keep on going. And then this is the corresponding probability, p1, p2, p3. So if you look at this x4, we're talking about exactly this table. So let's say my x1 is 0, x2 is 1, x3 is 2, and x4 is 3. And their corresponding probability, p1 is 1/8, p2 is 3/8, p3 is 3/8, and p4 is 1/8. So once you know that you can make a probability table, you can find its mean, or we can say the expected value. So when we are looking for the mean in terms of probability, we use this word expected value of x. And we denote it with this symbol, and which is the mean of x. So when you are looking for the mean or the expected value of x, first of all, you need to know how to make this table. Once you make this table, finding the mean or the expected value is not hard, because what you are doing to calculate is you are multiplying the value of x with its corresponding probability, and then you are adding these. So you are multiplying x with the probability and adding it. And let's do in this example. So if we are finding the expected value of x, we take a random variable x. You can take it y, z, whatever you have it here. You're finding the expected value of that. So expected value of x in this case is you are multiplying their values with their probabilities and then adding it. So expected value or mean is 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. So you multiply with probability with their values, x1 with their pi's, and then just keep on adding. And when you solve it, you will get the expected value of that random variable, x. So here we are talking about x as the number of heads. So we are looking at the expected value of, or mean of, the number of heads that you get. When you solve it, you get it. So there is not much work when you calculate the mean, but this mean is little different, or you can say the formula for calculating the mean is different, because earlier we talked about the mean or the sample mean. You add everything and divide with the total, and that gives you the sample mean, x bar. So here you are not dividing, because we know their corresponding probabilities. So you are multiplying with their corresponding probabilities and adding. So x1 times the probability, x2 times the probability, 3 and 4, and that will give you the expected value or the mean. So you can do that as sum of x1 times p1 p3. In this example, we have up till p4 or x4, and depending upon how many you have. So sum of xi times p. How many x you have, their corresponding probability, and you can plug those, and that will give you your expected value or mean of that particular random variable. Questions? So let me go back to your slides and let's talk about what we just discussed. So random variable probability model describes the outcome of a chance process and the likelihood of those outcome occurs. And we talk about this, consider tossing a fair coin 3 times and the number of heads we obtain. And this is exactly what we made. So this is the table that we just made by tossing a coin 3 times. And these are the outcomes. When 0, there is one outcome. So that's why the probability is 1/8, 3/8, 3/8, 1/8. And then you can make a histogram also, or if the histogram is given, you can see the shape of the distribution. And once you do that, then you will look at their corresponding probabilities. And we talked about this last time, but we did not go in detail. So we said that a discrete random variable takes a fixed set of possible values with the gaps between. The probability distribution of discrete random variable has the x, the values, and their probabilities. And again, these probabilities should satisfy two rules, that they should be between 0 and 1. And when you add everything, it should be 1. Then you can find the corresponding mean or expected value using the formula that I just provided you. And there is an example here also. So let me go with that first. Here, so this is what we just discussed. When analyzing discrete random variable, we will follow the same strategy we use with quantitative data, describing the shape, center, spread, and verify any outlier. The mean of any discrete random variable is the average of the possible outcome, with each outcome weighted by its probability. So that was not the case when we discuss in chapter 1, when we look at the shape, center. So when we were looking at the center, we find the mean and the median, right? So we are finding the mean, we are looking at the same way, but finding the way of mean is different because now I have more information. I know their probabilities also. So when I'm looking for the mean or the expected value in terms of probability, this is the formula we use. And again, it depends how many x or how many random variable, how many values of that random variable you have, and then you can multiply their corresponding probability. And this summation sign tells you that your I varies from 1 to n, so your x can be up till n. X, your random variable, we are just talking about 3 here, but what about the outcomes? X is 5, 7, 9. So you just keep on doing. Multiply with the probability and add. So finding the mean is not too much work. But when we are finding the variance, it is a little bit work. But to find the variance, first thing is you need to find the mean or the expected value. You know that the mean, we use this symbol, and we are using mu x. That means we are talking about the mean of the x random variable because we take it in x. If you take it as y, then you can say that mean of y. So mean of x is the expected value of x. So this, if this part is not given and the question is asking you find mu x, you know that you are finding the mean of the random variable x with their corresponding probabilities. To find the mean or the expected value of x, multiply each possible value by its probability and then add the product. So again, finding the expected value is the easy way. You just multiply with the corresponding probabilities and add everything, you get the mean. Earlier, we were adding everything, then dividing with the total because we do not know their probabilities. We were looking at the sample mean. Now we are looking at the expected value in terms of their probabilities. And here is another example that is solved for you. So in the previous example, we have only 4 x values. X was 0, 1, 2, and 3. Now we have the value of x is from 0 up till 10. So we have 11 observations, and the question is asking, it's asking the probability of for x, which is APGAR score, is shown below in this table. Show that the probability distribution x is legitimate or a correct model to work with. If you are looking for if it's a right model to work with, again, we need to satisfy our first 2 rules, which are this. So take a look at this question and tell me, do you think these 2 rules are satisfied here? Take a look and let me know.
Yes.
Yes. So all of these are between 0 and 1. And when you add everything, it adds up to 1 whole. So my first 2 rules are satisfied. This is a legitimate probability model to work with. Now I say that make a histogram of the probability distribution. Again, you will not be asked to make it a histogram, but you should know how to read it because we talk about the histogram in the previous chapters, how to look at the shape of the distribution and see what kind of distribution we are working with. So if we look at this histogram, what do you see? Or what do you say about this histogram?
Skewed left.
Skewed left. So just looking at the histogram gives you an idea. You have the table, you have their corresponding probabilities, you see it's a right model, and when you look at the histogram, you see that the distribution is left skewed. And then it says that the distribution is left skewed. An Apgar score at high ends. Newborn will have an Apgar score at the high end of the scale. So newborn here. And there is a small chance of getting a baby with a score of 5 or lower. So because that is the minimum, you have it here. So again, the basic idea is when you look at the histogram, you know what is the shape of the distribution. Then read your question and then you can explain what that left or right or symmetric distribution talks about. Now the next one says that Apgar score of 7 or higher indicate a healthy baby. And what is the percentage of healthy baby in this data set? So when it says 7 or higher, so pay attention to the word this. Or, what does or means in the terms of probability notation? What symbol we use for or? Union, right? So probability of 7 or higher. So that means 7 is included. 7 or higher. So 7 or higher. So greater than 7. And equal to means 7 is also included. So now we will go to our table and then we are looking for probability of. So let me just write it here. If you see something like this, what does this mean? This means probability of X is 7 because you have equal sign plus, and these are all disjoint events. So we talk about only 2 disjoint event A, B. So now we are talking about this is my A, this is my B, this is my C, this is my D. Anything that is given in the table more than including 7 and more. So this is my first, then second, then third, and then fourth. So these are my 4 disjoint events. I'm using the addition rule for disjoint events. So I will add this, 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 and this is the answer that I get. And then I can convert, I can multiply it with 100 and I'll get in percentage. And you can say roughly it's 91%. And then you can explain in words. So again, read what the question is asking, and you have very similar questions in your homework assignment also. I hope you all started working on that. I did extend the date for your 4.1 to 4.3 though, but make sure do not work on it at the last minute because you have 2 homework assignments on this chapter and a quiz. Okay. So the same example, and I will suggest you guys after the class or whenever you have time, work on this example and see how do you find the mean of X or the value of Apgar score with their probability using the same formula that we did. You multiply with their corresponding probabilities and add, and then you check if you get the same answer. And you should get the same answer because you are just multiplying the X values with their individual probabilities and then you are adding them. Exactly the same way we did the example for tossing a coin, and X was my number of heads. Here, X is your Apgar score, and you have up to 10. So you have 0 to 10. So you have 11 values, their corresponding probabilities. Multiply them and you get it. So the mean Apgar score of the selected newborn baby is 8.128. And again, go back to your question and see what the question is asking. The whole point is first you need to know what you mean before you explain what that mean is talking about or the expected value. The expected value does not need to be possible value of X or any integer. It is a long-term average over many repetitions. And again, we are talking about this is a long-term because we are talking about probability or the chance process. So we are talking about that this value is coming out after doing long-term or doing over many repetitions. Okay, so I think I skipped continuous distribution. So let me come to this part now. So continuous probability model, we talk about discrete probability model where we know how many set of outcomes are there, but we do not know how many set of outcomes are there when we talk about the specific range or the interval. So we are talking about continuous probability model. When we try to measure something, then we use continuous probability model. When we try to count, then we are talking about discrete because we can count how many outcomes are there. So a continuous probability model assigns probabilities as area under a density curve. And we talk about two type of density curves in chapter 1. So we are going to use those two concepts again in this chapter. And since we have already done that, it's very easy to use the same concept and see how we are using the same concept using the probability notations. The area under the curve in above any range of values, the probability of outcome in that range. So we did this in chapter 1, and you all know that it's a rectangular shaped distribution, so we call it as uniform distribution. The question is asking, and again when we are talking about density curve, two rules still satisfy, that it is on and above the horizontal axis and area under this curve is one whole. So the area of this rectangle is one whole. So these two rules a density curve should satisfy. We know that it's a density curve, so these two rules are there. Now it's asking you find the probability of getting a random variable that is less than or equal to 0.5. And again, if you see this word is given you in full caps, or greater than 0.8. And or means we are using this notation. Either less than equal to 0.5 or 0.8. And when we say union, so we are saying at least one of them should occur, either left or right. So when we are talking about less than equal to 0.5, first let's write it in this notation, or let's draw it. So here you shaded 0.5. So we are talking about less than equal to. So this is less than equal to 0.5. That means 0.5 is included up till here. And again, when we talk about continuous distribution, either you take the equal sign or you don't take the equal sign. It's not going to change anything because we know that the probability at x equal to 0.5 is 0. Because in continuous distribution, you cannot find the probability at any specific point. You can find in the range. So if you include equal or do not include equal in continuous probability model, it does not change anything. But in discrete probability model, it will change. And let me use the same example to show you how it will change. Here it says that probability of x greater than equal to 7. If I forget to write equal sign and I have just this part, greater than 7, do you think the answer of both will be same? If I have probability of x equal to 7, which one is more?
Equal to 7.
Equal to 7, because you included 7 here also. Included 7. But here we say greater than 7, so 7 is not included. So we are talking about only 8, 9, 10. So we are missing this part. So in discrete, this equal sign, less than equal, greater than equal, matters because it will change your answer. But in continuous, either you have that sign or you don't have sign. It's not going to change anything. If you forget this part, you still get the same answer. So either you say less than equal to or less than 0.5, it's not going to change anything. So I'm talking about this part, the probability of this or this. So either this or this. Are they overlapping events? The shaded part, are they overlapping?
No.
No. So they are not overlapping. They are separate, or we can say that they are disjoint events. And when they are disjoint event, I know the addition rule for disjoint event. Its probability of A union B is their individual probabilities. So if I find the probability of this, which is my A, and this, which is my B, and I add them, I get probability of A or B. So first of all, see if they are disjoint evens. They are not, then you can use this. And I'm assuming that we all know how to find the probability of this part or this part. So let's do a quick recap of this one. How do we find the probability or the area under a rectangle shaped curve? So first of all, what we do, we look at the length of the distribution. And we know that here it is 1, right? If this is 1, that means the height is also 1. Height is the reciprocal of that. So how much is this? 0.5 times 1. So this will be 0.5 times 1. And this will be, how much is the difference here? 0.2. 0.2 times 1. So the area for this one is 0.2 and area for this one is 0.5, because we know that the area under the curve is 1 whole. And the height, how do you find? Whatever you have, you do the reciprocal, you get this. And if we are talking about here, so let me just write this on the side. Probability of A union B, and which is my A is less than equal to 0.5 and my B is 0.8. And this is your disjoint event is probability of A plus probability of B. So you can find this and this. If you forget to write the equal sign, that is also fine, but it's better to write it. But this equal sign in probability of continuous probability model tells us that probability of X at any particular point is 0. And make sure you read the question in your homework assignment, because the homework assignment, there are questions on discrete as well as there are questions on continuous probability model. So read the question carefully. If the question is asking about to calculate the probability for discrete or continuous probability model. Because for continuous, this part is 0. All right. So this is about normal distribution, and we talk about normal distribution in chapter 1 also. And we also talk about 68%, 95%, and 99.7%. We say that area under 68% is within 1 standard deviation, 2 and 3 standard deviation. We also use the standardized normal table, table A, where we standardize our z, which is x minus mu over sigma, and we use normal distribution with mean 0 and standard deviation 1, and how to calculate the corresponding area, either using the table, and we also use calculator to calculate the area under the curve using normal CDF. Exactly the same thing, we are doing it here. Let's look at the next example, which is talking about the same what we did earlier. So often the density curve used to assign probability of intervals, probability to intervals of outcomes in the normal curve. And again, when you are talking about density curve, we are talking about continuous probability model. And in continuous, we talk about the range or the interval. So here is an example. Women's heights are normally distributed with mean 64.5 and standard deviation 2.5. If we pick one woman at random, what is the probability that her height will be between 68 and 70? So you are looking at the interval axis between 68 and 70. So if you are looking at the interval, again, you are looking at a specific range. So you are talking about a range, and you know that you are working with normal distribution. So we are looking at the specific range under normal distribution, or think that we are looking at the area under that specific interval. And that means we are talking about either using either using our table A or using the calculator to find that probability. So because the woman is selected at random, X is a random variable. Now, if you are looking between 68 and 70, again, 68 and 70, before you calculate, if you're using the table, you need to calculate your z-score. The formula is the same that we used before. So you calculate that. Once you get these values, you can go back to the table, find their corresponding area, and then subtract that to get it. We have done that before. Make sure you take a look at this question. If something not making sense, let me know. Can we apply 68, 95, 99.7 rule here in this specific question and get the answer?
No.
No. And why not? Because when we look at this 64.5 and 2.5, when you add, you will not get this range. You add or subtract, you will not get the range of 68 to 70. If you get that range, then you don't have to use the table. Then you can work with your 68, 95, 99.7 rule. So here, when you look at this 64.5, then you add 2.5, it will become 67. That's your first standard deviation. And that's your second standard deviation. And this is between your second and third standard deviation. So you are looking for this area. Or you can use your calculator to find your minimum is 68, your maximum is 70. You have your mean, you have your standard deviation, and you can just use your calculator, do normal CDF. You have all these 4 values, plug it, and you get the answer. Exactly same what we have done before. Now, just here we are saying that we are using continuous probability model to find the probabilities of those intervals. And in the beginning, we said that probability is the proportion of observations that you get when we do repeated trials or in the long run. So this is about continuous distribution. 4.1 to 4.3, we covered 4.1 to 4.3. So I think you are good to do your first homework assignment. And we also talk about the mean of the random variable and rules for the mean. We still need to do the variance. So let me just quickly talk about how to calculate the variance. We still have 3 minutes, but maybe we will talk about this in more detail in the next class. So and then we will talk about the rules for the mean. So variance. So when we are talking about variance, we are talking about how far each observation away from mean, right? That's what we say in standard deviation, and then variations around your mean. So we calculated the mean, and now when we are working with the variance, now we are looking for how to calculate that. So for finding the variance, first thing you calculate the expected value or the mean. Once you calculate that, if you remember earlier, we used this formula to calculate the variance. Xi minus x bar square. This was our variance, and then we calculated standard deviation. We did the square root of that. We are still using the same formula, but we are not using this denominator part because now we have the probabilities. So what we do, we will subtract the mean from each observation, do the square, and multiply with its probability because now we have probability. So what you do, you calculate the mean, what you have here, and then you subtract mean from each observation, do the square, so you get positive values. And when you subtract the mean is bigger or smaller depending upon what you are looking. On the left side of the mean, when you subtract, you get negative values. On the right, you get positive. So you square it. Once you get that, then you multiply with the probability and then add. So you have to do an extra step when we talk about the variance. In the mean, what we just did, we multiply this and then add in, and that was my mean or expected value. In variance, we do one more step. What we do x1 and then subtract this and then doing the square, and then so this part is changed to this part. Same thing, x2 minus mu x, do the square, e2, and then keep on doing. And that is your variance or sigma square. And if we need to find the standard deviation, once you calculate that answer, do the square root of that, you will get the standard deviation. So that is how we calculate variance. So variance, again, when we calculate variance before, we need mean because we are looking at how far each observation or what are the variations around the mean. So first thing, to find variance, we need to calculate mean. Then subtract the mean from each observation, multiply with its probability, subtract, multiply with its probability, and then keep on adding. So the earlier formula for expected value or the mean is this, and for variance. So for variance, we need this. This is mu x. So you subtract mu x from each and then multiply with its corresponding probability. So I think I will stop here. There is an example in the slide. Take a look at that. And then we will talk about the rules for mean and variance on Friday's class. And we will also talk about conditional probability. And in Monday's class, we will talk about Bayes' rule. And then we will be done with this chapter. And then we will have 2 review sessions. And then following week is your test on chapter 3 and 4. Thank you, everyone. I'll see you guys on Friday. Have a wonderful day.
Thank you.
You're welcome.
Thank you.
You're welcome.